We're going to model how a fever kills pathogens when we are sick. So the pathogen has breached the first line of defense and it is overwhelming the white blood cells in our body. So when that happens, remember the pyrogen chemicals are sent to the hypothalamus, and the hypothalamus says, okay, it's all right to operate at 38.5, 39 degrees Celsius. Remembering that for thermoregulation and optimum homeostasis, that the human body needs to stay at 37 degrees. Now, yeast is a living thing. We're going to feed yeast with sugar dissolved in water, and you can see the reaction up there. Yeast is a living thing. It's not an animal, it's not a plant, it's in a class of its own. When it digests or engulfs sugar, it forms carbon dioxide gas and ethanol. And this is the same ethanol that you see in E10 petrol, in alcoholic beverages, and it's made through a chemical reaction called fermentation. Now, the optimum temperature for yeast metabolism is between 35 and 55 degrees Celsius. So when we conduct our experiment, we're going to make the environment for yeast around about 35 degrees Celsius, and then we're going to trial one at 45 degrees Celsius, which is halfway between the 35 and 55, and then we're going to model the fever part by doing that fermentation reaction so that it is above 55 degrees. So in other words, yeast was a pathogen, and we know that it can't live or should not live above 55 degrees, that if a host responded with a body temperature of 56 degrees, say, then it should kill that pathogen, and then we would have modelled how fevers kill pathogens. So this is the first run, official run. I've done a trial. I'm getting my 150 mils of water. I'm using a measuring cylinder to deliver that 150 mils of water, because even though this beaker has markings on it, they're not very accurate. Right, so this bit of equipment allows me to deliver water to the nearest mill. Now, after my trial, I noticed 35 degrees Celsius is not a high temperature, and it's a cold day. And what I noticed during the trial is that the temperature dropped down to about 34, which is below the activation temperature of yeast. So I've included this little resin heater here just to stop it dropping below that 35. I need to add the sugar, which is 1 tablespoon of sugar. So accuracy is key to a valid and fair test experiment. So I've used an official measuring spoon. And now I need to stir that. So I've stirred in the tablespoon of sugar. It's just starting to drop below 35 degrees, and it's time to add the yeast. Once the yeast is added, I've got to be pretty quick, and I've got to record some levels, because we're measuring the amount of carbon dioxide the yeast produces by measuring the height of the carbon dioxide foam bubbles that will be made. And the sugar is food for the yeast. In goes the yeast, all at the same time. I've pre-measured it out, getting some, and it needs a good stir. And I've started my timer, and I'm going to mark where the liquid level is now. Now this is interesting. We've reached the 5-minute mark, and liquid level has dropped, and using parallax error, the foam level is just above where it was at 0. So it's like the liquid has been replaced by the foam, which is... We are now 10 minutes into the fermentation. My temperature is still sitting on 36 degrees, so that hasn't moved, it hasn't dropped, so that's good. And I'm going to mark where the foam is now and call it 10. We're now 15 minutes into the fermentation, and we're getting a lot of foam now. My temperature's only dropped 1 degree, so I'll mark the 15 mark. It's now 20 minutes into the fermentation, and the carbon dioxide bubbles that have been produced, so it's about there, and that is 20 minutes, and we'll stop it there. Okay, time to start the 45 degree trial, and I'm marking the original liquid level. We know that that will change soon. 5 minutes into the 45 degree fermentation, although I've got a bit of a problem in that I'm struggling to maintain that temperature at 45. It's dropped to 41.5 degrees, but it's a lot closer to optimum than the other one was. So I'm marking my new level at 5, and at least it's not below the 0 line this time. So there's 5 minutes. 10 minutes into the fermentation, and it's already looking a lot different from the 35 degree one. We're up here for 10 minutes, and I've got the tape from the last one, so here we're getting probably close to 10 mils, maybe even more. Okay, 15 minutes into the fermentation, and I've got to make sure, because this is higher, I've got to make sure I measure in the same place all the time. That is part of keeping the experiment fair, doing a fair test, and making it valid and controlling it. So here we are at 15, and so we're at the end of the fermentation, 20 minutes, and what's just happened is that dome collapsed, but it didn't seem to affect the level that we're measuring, so that is good. Alright, so we've got 20 there. So here we are at 55 plus. I really wanted, I used boiling water, so I really wanted something close to 100. And I had to be really quick with the sugar and really quick with the yeast because I'm losing temperature fast. So I'll just mark the 0 there. Now don't forget, we're modelling how fever kills pathogens. So for us, our optimum temperature is 37 degrees, and during a fever, our hypothalamus will allow our temperature set point to 38.5 or 39 degrees Celsius. Now, for yeast as a living thing, its optimum temperature is 45 degrees. So a fever for yeast should theoretically be something a little bit higher than 55 degrees. So at the moment I've got just, it looks like 56.5. So now we're 5 minutes into the high temperature fermentation, and it's not looking too good. It's, I have to mark, the foam is lower than the 0, so it's like the 35 degree one where I have to... We are 10 minutes just into the fermentation at 55 plus degrees. And as we can see, nothing has happened. So the fever has worked. It has killed the yeast. And there's proof of that down the bottom here. You can see sediment, and that is just the yeast. So 20 minutes now into the fermentation, the temperature is optimum at 44 degrees and nothing has happened. It's now time to compile my results from the experiment, and I'm pleased I did these tapes. I hadn't done this experiment before, so I just did a muck around trial just to see what to expect. But here's our 35 degree measurements. Here's the 45 degrees for most of the experiment, and there was the 55 plus degrees. So I've got this square here, and I'm just going to use the machined edge of the tape So next I've drawn my lines now to make things a bit more accurate, and I'm still going to use my accurate ruler here to measure in millimetres the height of the foam. So I'm going to call that 2 millimetres. It's like 9 millimetres. 0 to 15 is 19 millimetres, and 0 to 20 is right on 30 millimetres. So doing the 45 degree one now, that is 29 millimetres, and we've got 39 millimetres. So I haven't plotted the results yet, but already we can see that 45 degrees was definitely the optimum temperature for the most carbon dioxide production